Hello, ladies and gentlemen, and today must be Tuesday. Congratulations on walking across the stage last night. That was wonderful to see all of you. You all were looking so grand and dapper and all mature like. So, good news, we've had the ceremony for graduation. Bad news, we still have a final exam to get through before that actual graduation takes hold. So we are looking at section 3.4, intersection of lines. You've used today, hopefully you're going to use today to solidify your knowledge of 3.3, which was independent work from your black textbook. And you're moving on to 3.4 using these lessons. Okay, so what are the possible ways that two lines in a plane can intersect? They can be parallel and distinct. Okay, so these two lines are parallel and they're definitely distinct. They're different lines. Or they could intersect at one point, or they could be coincident, meaning that the two lines are in fact the same line, or if you insist on thinking them as two different lines, that they lie on top of each other. So once again, in two space, we can have lines be parallel and distinct. We can have lines being intersecting at one spot, and we can be coincident. Now, I used the word two space, and when we read the definition before, we said in a plane. Now, that's an important distinction. It means the same thing. So if I'm talking about a plane, I'm talking about an x, y coordinate system, which would be here. So that would be a plane. That plane could also be vertical, it could also be slanted, we could put it anywhere we want. But a plane itself is composed of two dimensions. So that's the same as saying in two-dimensional space. Okay, so what I'm going to do here is we're going to look at example number 1. Oh, good news, and just a bit of interesting note here. The LMS isn't accepting any videos to be uploaded, so what I've learned how to do, which is kind of cool, is I've opened a YouTube channel. Go figure, Mr. White's YouTube channel. And we're going to upload this stuff to YouTube, and we're going to put the links in the LMS, and you're going to watch it from there. So things are going to be a little bit different in watching some of these videos in the sense of how it opens up maybe in your browser, or you might not be able to download it. I don't know. But what's going to happen is it's going to be hosted on a YouTube channel that's going to be private, and I'm going to take the links and I'm going to put the links within the LMS, and you're going to be able to get to it through the LMS. Okay, so there you go. Example, determine if the lines intersect at any point of intersection. Determine if the lines intersect and any point of intersection. Now it's important to note here at this point, no intersection is considered a way of intersecting. Okay, so they could intersect at one point, they could intersect at an infinite number of points, or they could not intersect, which is a way of intersecting in mathematics. I know, sounds a little weird, but that's just the way it is. What would it take for two lines to be parallel? Well, for two lines to be parallel, they would have to have scalar multiples of the direction vector. So for this one, you'd need scalar multiples of the direction vector, and this one you'd need scalar multiples of the direction vector. What would be the difference between these two? Well, this one would have no points of intersection, and this one would have an infinite number of points of intersection. Notice that this case happens when the direction vectors are not scalar multiples. In fact, the direction vectors are different directions, if you will. So that's going to give us this situation. And in two space, if two lines do not have the same direction, it's analogous to us talking about them having different slopes. Now, this does not necessarily mean perpendicular slopes. Don't make that mistake. This is not a 90-degree angle. It just means that the two direction vectors are not the same, not scalar multiples, which means that they will intersect at some point. So the first thing we're going to look at is we're going to examine the direction vectors. So if I turn it like that, and if I turn this like that, everything's wonderful. So examine the direction vectors. Okay, this guy has a direction vector of 3, -2. This guy has a direction vector of 2, 1. Take a look at them. What would I have to multiply? Well, this is an easy one. What would I have to multiply -2 by to get 1? I'd have to multiply it by -1/2. Well, if I take 3 and multiply it by -1/2, I get -1.5. I don't get 2. So, therefore, direction vector 1 is not a scalar multiple of direction vector 2. where k is a scalar value. Okay? Therefore, these lines must intersect. And they must intersect, since we're in two-dimensional space, at a single point. Okay, so now how are we going to find that single point of intersection? Well, what we can do is, let's see, there's a couple of different ways here. Probably the easiest way is to look at the parametric values. So for line 1, notice that you're going to have x equals 18 plus 3t1 and y equals negative 2 and negative 2t1. Those are 1s. And I just want to clean this up a little bit. Get rid of that guy. We don't really need him. And over here for R2, line 2 in this case, x is going to be equal to negative 5 plus 2t2, and y is going to be equal to 4 plus 1t2. Okay. Now at a point of intersection, let's use this one for example. At a point of intersection, notice that for both lines, the x value and the y value at a point of intersection must be the same for both lines. So whatever the x value is at this point is the same x value for both lines, and the same is true for the y value. So I'm going to go so far as to say, at any point of intersection, x will equal x, and y will equal y. Which means that this x must equal this x. So therefore, at the point of intersection, if I rearrange this, I can get 3t1 minus 2t2, negative 5, and the negative 18 going over to the other side would be 23. I'm going to call that equation 1. And over here, if I say y equals y, then it will be negative 2, negative 2t equals 4 plus t2. That should be a t1. So if I move these around, now what I'm going to do is I'm going to move this guy over to this side and bring this over this way. So it's negative 6 equals 2t1 plus t2. And then I'm just going to rewrite that. 2t1 plus t2 equals negative 6. I'm going to call that equation 2. Now what you're going to remember is that from grade 11, they taught you how to use elimination. So using elimination, I'm going to take 3t1 minus 2t2 equals negative 23. And I'm going to get 2t1 plus t2 equals negative 6. Now what I want to do here is I want to take a look at that. I'm looking for another pen. And I want to change it so that the coefficients in front of one of the variables is the same. So if I multiply the bottom one by 2, I'll get 4 t1s, and I'll get 2 t2s, and I'll get negative 12, which means that I'd then be able to add them, and the negative and the positive t2s would cancel out, leaving me with only t1s. Or I can multiply the top by 2, I can multiply the top by 3, or sorry, the bottom by 3, and I'll get 6 t1s and 6 t1s here, and then reduce them. It doesn't really matter. Probably just for sake of argument at the moment, let's multiply the top one by 2. Let's multiply the bottom one by 3. So this will be 6t1 minus 4t2 equals negative 46. The bottom one will be 6t1 plus 3t2 equals negative 18. Now what I'm going to do is I'm going to eliminate. What do I need to do? I need to subtract, because 6t1s subtract positive 6t1s will leave us with no t1s. It'll leave us with negative 7 t2s. Be careful with that. It's negative 4 t2s, subtract 3 t2s. Oh my goodness, so this is negative 46, subtract, so that's actually going to be plus, reaching for my calculator because I don't want to make a mistake. So it's going to be 46 minus 18, so it's going to be negative 28. Dividing both sides by negative 7, what we're going to end up with t2 equals 4. Once we know what t2 equals, we can use that and we can sub it back into, if we know what t2 is and if we want to know what t1 is, we can sub it back into here. Or we can sub it back into here, it doesn't matter. Sub into 2, simply because negative 6 looks easier to work with than negative 23. So it's going to be 2t1 plus, t2 is 4 in this case, equals negative 6. So you're going to get 2t1 equals negative 10. t1 equals negative 5. Therefore, the point of intersection is equal to negative 5, negative 4. Wrong. Absolutely wrong. That's t1 and that's t4. That's not the point of intersection. The point of intersection needs to be this x and this y. And you're either going to use t2 here, or you're going to use t1 here. But this, ladies and gentlemen, means nothing. All right? Please understand that. No way, no wow, cannot happen. Yes, I did that on purpose. What you need to do now is you need to come up with what the actual point of intersection would be using the values of t2 or t1. Noticing that we didn't need to find t1. We could have stuck with just t2 as long as we plug it up into here. So using t2 equals 4, you know that x equals negative 5 plus 2t2, which is going to be negative 5 plus 2 times 4, so that's 8. So that's going to be 3. And y is going to be equal to 4 plus t2. t2 is equal to 4, so it's going to be 4 plus 4, which is 8. And that's wonderful. You can't see what I'm doing. But that's wonderful. That works out beautifully. I'm going to scroll back here just a little bit so you can see what's happening. So your point of intersection is 3, 8. Now what if you had found t1 first? What if you didn't reduce out t1s here, but you didn't reduce out t2? Well, then you would have come up with a t1 value of negative 5 using r1. I'm going to come up here so that you can see it. So t1 was equal to negative 5. Using your r1 values, here they are here, x would equal 18 plus 3 t1, which is 18 plus 3 times negative 5, which is negative 15, which is 3. And y is going to be equal to negative 2 minus 2t1, which is negative 2 times negative 5. So that's negative 2 plus 10, which I believe is equal to 8, which gives you the point of intersection of 3, 8, which is the same as above. There you go, ladies and gentlemen. That's how you do it for those ones, and we'll come back with the next examples.